us to find values a, b, c, d, and p in this equation here. You'll notice that these variables appear, b, c, a, d, and p. I mean, there's a lot of unknowns, and we're going to have to use some ideas that kind of a little bit go beyond the scope of, your typical grade 11 problem. So let's start by looking at maybe these restrictions here. Okay, we know that x cannot be p and x cannot be 9. Now, I guess the obvious question is, well, what is p? Well, where can we get a restriction from in our expression up here? Notice that, let me just erase this. Here is a denominator. Over here, we have this denominator, which is some kind of quadratic, which hasn't been factored. We have a denominator here, and we have a denominator here. So listen, I'm going to maybe go out on a limb a little bit, but it seems reasonable to think that this p-value has something to do with this factor, and you know what, I could just make 9 the value of d. So let me just state that. I'm going to say d is 9, because that would be a restriction. And for p, I'm just going to solve this here. So I get 3x plus 4 equals 0. That's when the value will be 0. And I end up with x equals negative 4 over 3. So I think it's reasonable at this stage to say, okay, let p equal negative 4 over 3. And those are our two restrictions. So we have values for d and a value for p. And now we're going to get on to this stuff here. Okay, what happens over here with b and c, and what happens with this value a? Now, just focusing on the right-hand side, we know that if we're going to combine these fractions together, they have to have a common denominator. So this guy here will have to be multiplied by some linear term so that I get a quadratic. And the linear term that you're looking for is actually this guy over here. So let's do that. Let's just focus on the 3x plus 4. And I'm going to multiply that by x minus 9. Again, d is now 9. And let's see what I get. If I multiply this out, I'm going to get 3x squared minus 27x plus 4x minus 36. In other words, I'm going to get 3x squared minus 23x minus 36. And by the way, if I multiply the denominator by x minus 9, I'm also going to be multiplying that numerator by x minus 9. So let me just tidy things up here and see what we have. So I got 2x minus 9 all over this denominator here, which we got by multiplying out those two binomials, these ones up here. And then I have minus my numerator, which is just 1. And then I have this trinomial, 3x squared minus bx plus c equals ax minus 17. And that's all going to be over, well, really, it's going to be all over this. Because, remember, these two guys up here is just this here, which I've expanded into this term, so they have to be identical. Well, it looks like over here things start to emerge. The b value, the c value, the a value. Notice how all these coefficients line up. What do you think? Again, we are adding these. My b and c value have to be. Well, b looks like it's going to be 23. And c, will be negative 36. I mean, if you want, that's negative b, negative 23, which just becomes b equals 23. So we have that down. Now we're left with the a value. But remember, these two fractions can be combined. So I get 2x minus 18 minus 1 all over that common denominator. I'll just take this guy here. And get rid of these highlights. And that whole thing is going to equal ax minus 17 over, again, all this business here. Okay, looks like we're making some progress because 18 and negative 1 is going to give me, oops, did I multiply that by the right term? Let's take a look here. Oh, that's my mistake. This should be a plus. So that should be a plus. So it'll be 18 plus 1. That'll give me negative 17. And these equations, these expressions are almost exactly the same. Actually, they are the same, because all we need to do now is make a equal 2. So look, we have now determined values for, I'll highlight them one at a time. I have a value for a, I have a value for b, I have a value for c, I have a value for d, and I have a value for p. Now, as an exercise for you, I want you to check that this is true. In other words, go back to the original equation up here and substitute in for all the unknowns, b, c, a, and d, and p, all the values that we found, and check that the left side equals the right side. If it does and it works out, we have a solution.